video, we are going to see about a project titled A New Model for Calculating the Maximum Trust in Online Social Networks Using ABC, Firefly and MABC. Coming to the introduction part, in this introduction, we present a new and innovative model for calculating the maximum trust in online social networks, that is MTOSN, using a combination of three powerful optimization algorithms that are artificial bee colony, that is ABC, Firefly algorithm, and modified artificial bee colony, that is MABC. The objective of our proposed model is to address the limitations of traditional trust evaluation methods by efficiently capturing dynamic and complex trust relationships in online social networks. By leveraging the collective strengths of ABC, Firefly algorithm, and MABC, our model aims to maximize trust levels between users and content, fostering a safer and more trustworthy online social environment. Through extensive experiments and comparisons with existing methods, we demonstrate the effectiveness and superiority of our approach, offering a promising solution to enhance user interactions and content sharing in online social networks. So our main objective for this project is to provide a comprehensive, accurate and effective approach to calculating maximum trust in online social networks. By leveraging the strengths of ABC, Firefly algorithm and MABC, the model aims to offer a synergistic solution that enhances the reliability of trust evaluations and fosters a safer and more trustworthy online social environment. Through extensive experiments and comparisons with existing trust evaluation methods, we demonstrate the effectiveness and superiority of our model in maximizing trust and facilitating meaningful interactions among users in online social networks. To address these challenges, our model incorporates three powerful optimization algorithms that are artificial bee colony, Firefly algorithm, and modified artificial bee colony. The integration of these algorithms aims to enhance the accuracy and comprehensiveness of trust evaluations, thereby maximizing trust levels between users and content. Now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. So in hardware requirements, first we have operating system, that is Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first we have upload Facebook dataset. This step involves uploading a dataset related to Facebook user interactions or social network activities. The dataset may include information such as user profiles, friend connections, posts, likes, comments and other interactions within the social network. Uploading the dataset is the initial step in the process and provides the necessary data for subsequent analysis and algorithm execution. Second, enter source and destination user ID. After uploading the Facebook dataset, the user is prompted to enter the source and destination user IDs. These IDs represent two distinct users within the social network. The source user is the user whose interactions will be analyzed, and the destination user is the user to whom the source user's interaction will be compared or linked. Third, run ABC algorithm. The artificial bee colony, that is ABC algorithm, is a nature-inspired optimization technique used to solve complex problems. In this context, the ABC algorithm is applied to analyze the interactions of the source user from the Facebook dataset. It may evaluate the frequency of posts, likes, comments, or any other relevant social network activities performed by the source user. Fourth, run Firefly algorithm. The Firefly algorithm is another optimization technique inspired by the flashing behavior of fireflies. In this step, the Firefly algorithm is executed to analyze the interactions of the destination user from the Facebook dataset. The algorithm may focus on aspects such as the number of friend connections, post engagement, or other social network activities of the destination user. Fifth, run MABC algorithm. The modified artificial bee colony, that is MABC algorithm, is a variant of the ABC algorithm that introduces innovative adjustments to the optimization process. In this step, the MABC algorithm is used to analyze the interactions of both the source and destination users from the Facebook dataset. The algorithm may consider a combination of features from both users and explore potential connections or correlations between their activities. 6. Comparison graph. After running the ABC, Firefly, and MABC algorithms, a comparison graph is generated. This graph visually presents the results of the analysis, allowing for a comprehensive comparison of the interactions between the source and the destination users. The graph may illustrate the frequency of specific activities, the similarities or differences in their behavior, or any patterns discovered during the analysis. 7. Exit. Here, exit indicates the end of the process or the program. In this context, it signifies the completion of the analysis and comparison task. The generated comparison graph and other relevant results are now available for interpretation and further use. The exit step of the it represents the conclusion of the process, and the user may proceed with further analysis or draw insights from the social network interactions of the source and destination users. Now coming to the execution part. Execute the project. First we need to open the code folder. Here we can see that there is a folder named as dataset. In this we are containing a .csv file with the name as Facebook. Here this is a Python file, OSN trust calculation. In this it contains a Python script which is the main file of the code. Here trust users is a text file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on the run.bat file to execute the project. This is the graphical user interface. With this we are interacting with the program. Now click on upload Facebook dataset button to upload dataset. Now click on facebook.csv file and then click open. Here the dataset has been loaded over here. Now here you can see user ID, and then in square brackets we can see the friend list, and scroll down above output screen to view all users and their friends list. Here you can see. Now enter source and destination user ID and press all buttons one by one to calculate costs. So on source user you can enter 7, and on destination user you can enter 8. Now click on run ABC algorithm button to get the output. So here on this screen you can see 7 and 8 ID. We got cost value and then displaying ABC computation time. Now click on run Firefly algorithm button to get the output. Here on this screen you can see cost value for 7 and 8 user using Firefly algorithm. Now click on run MABC algorithm button to get the output. Here we can see we have got cost value using MABC and then displaying both source and destination as trusted users. Now click on comparison graph to get the graph. Here in this graph, x-axis represents algorithm names and y-axis represents computation or execution time in all algorithms. MABC took less computation time. Similarly, you can enter any source of destination and get cost values and user as trusted or untrusted. If you want, you can get source and destination users ID from the trust users.txt file. Now just close this graph and click on exit for completing this project. Now coming back to the In conclusion, our proposed model for calculating the maximum trust in online social networks using the combination of artificial bee colony, that is ABC, Firefly algorithm, and modified artificial bee colony, that is MABC, presents a powerful and innovative approach to enhance trust evaluations in online social networks. Through the integration of these advanced optimization techniques, our model achieves more accurate and comprehensive trust assessments, fostering a safer and more reliable online social environment. The demonstrated superiority of our model over traditional approaches in capturing dynamic trust relationships highlights its potential to positively impact user interactions and content sharing, making it a valuable contribution to the field of online social networks. The incorporation of the Firefly algorithm further refines the trust evaluation process, allowing for the reinforcement of trust relationships among users. Moreover, the modified artificial bee colony algorithm contributes to optimizing the convergence speed and overall performance of the model, ensuring a robust and efficient search for maximum trust.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.